So we're only going to be talking about laminas, which are thin plates, so they don't have any volume. And they have an area density. And this area density is called rho. And basically what rho is mass over area. And so with the lamina, we can actually calculate the area rather easily. And then to find the mass of the entire lamina, we can multiply area by rho to get mass. So mass equals area times rho. Okay, now let's try an example. So I'm going to draw out a lamina which is defined by two functions, f of x and g of x. So here's f of x, and here's g of x. And so we can see that we can easily calculate the area of this lamina from point A here to point B. And the area is basically just the area between these two functions. And to calculate the area, we can just integrate f of x minus g of x dx from A to B. And this is because when we do f of x minus g of x, we get a height here. And then when we multiply that by dx, we get an area. So we get dx and f of x minus g of x. And so after we found the area, we just multiply that by rho to get mass. And so this is the formula for how to get the mass of a lamina. So in earlier examples, we used point masses, and we took that mass and then we multiplied it by a distance from the mass to the reference axis or point, and that was how we found our moment. And the same goes for laminas. And so let's take a look at this small strip of this lamina. And in order to find the moment of this lamina, and the way we do that is by treating the center of mass as the point mass. And so you can think of this lamina as kind of like a curve of just point masses, and then we multiply that by the distance to either the x-axis or the y-axis to get our moments. Now let's derive the integral, formulas for these moments. So let's first take a look at the moment of a lamina about the x-axis. And we already know the mass by multiplying rho and area. Now we just have to find the distance. And at the center of mass of this strip of the lamina, we can see that the distance is pretty much just the average of f of x and g of x. So the moment of this lamina about the x-axis is going to be the integral from a to b. Now let's take a look at distance. So f of x plus g of x over 2. So now we have distance. Now we multiply that by mass. Mass is rho times area, which I have shown in the previous part of my video. So we have rho times, well, the height here is f of x minus g of x, and then the width is d of x. So we have rho times the area f of x minus g of x dx. Okay. And to find the moments of this, lamina about the y-axis, we have to consider the point with respect to the y-axis, and so our distance would just be the x value. So let's say over here the point mass we're considering is somewhere around here. then the distance to the y-axis would just be this x value here. Okay, so that means that the moment about the y-axis of this lamina would be the integral from a to b of just x, which is the distance, times mass, so that's rho, times, yeah, we can just use mass like here, f of x minus g of x dx. So hopefully you can kind of get a conceptual grasp of these two formulas for moments. Okay, now let's move on to the center of mass of laminas. Let's say we want to find the x-coordinate of the center of mass. In order to find that, we have to take the moment in the the moment about the y-axis and divide that by the total mass of this lamina. And the reason we're dividing the moment about the y-axis by the mass is because we have to look back at how we got the moments. And we got the moments about the y-axis by taking the distance this way, which is an x value. So when we divide all of our moments, I guess, by our mass, then we kind of get an x. We get a horizontal distance. So that's kind of where our x-coordinate lies. And the same goes for the y-coordinate of the center of mass. See, when we were taking the moments of the lamina about the x-axis, we were actually using a y value. So once we divide that by the total mass of this lamina, we will find kind of like a y-coordinate, and we'll see where on the y-axis the center of mass lies. So just remember that when you're looking at to find the x-coordinate of the center of mass, you want to kind of think of it this way, and then when you're looking about the y-coordinate, you want to think of it this way.